Hello everyone, and welcome to the blog on circular queues. As we just saw in the previous blog, linear queues are very easy, but they have a problem. And the problem is that they waste space once the array reaches the end of the array. So we're gonna simulate a circular queue. Rather than doing it physically, we're gonna simulate it by wrapping around the front and the rear. What do I mean by this? Well, let's assume that you have this queue, right? So in this queue we have how many elements? Well, it goes from front to rear. We have 3 elements there, 40, 18 and 40 again. Okay, and what happens if we append now? Now remember, rear needs to point to the first empty cell, right? Well, yes, it's gonna wrap around. And look how that has happened. It has moved from this position all the way to the beginning. Yes, it's pointing to the next empty element. The length has increased by 1 and rear has gone from 5 to 0. Okay, well that's great. It wraps around. What happens if we keep appending? Well, nothing much. It just works as usual. You increase rear, right? Increase rear and append this time 23. My length has increased again and rear has gone from 0 to 1. Okay, can I do it again? Yes, I can. And this time I'm appending 37. So there you go. 37 comes here. Rear moves by 1. So from 1 to 2. And the length now is 6. And at this point in time, I'm full. And how do we know? How do we know that it's full? Well, you know, just by looking at this, you can think, well, yeah, if self rear is equal to self front, the rear and the front are the same, that pretty much looks like it's full, right? Careful, because that can also be empty. It can also mean that it's empty. For example, do you remember when it's initialized? Rear points to 0 and front points to 0. So that cannot be the case. In this case is when, and it's actually quite intuitive, when the length of the queue is equal to the maximum capacity of the queue, that is equal to the length of the array, that's when it's empty, that's when it's full. And that is this, that before in the linear queue was not correct, is now correct. Okay, so the implementation is going to be very similar. We just need to wrap around rear and front and change our is full, right? So append and save would change and is full. How do we implement? Well, very similar to stacks, and the difference are going to be in red. You're going to see that is stacks. Very similar to linear queues, differences in red. Everything is going to be very similar. No difference there. The only difference is in the name. No difference there. Everything is the same. No difference, and just is full. Which, as we said, the only difference is that this is no longer self-rear, is the length of the actual queue. What is the big O? Well, exactly the same as the one for the linear queue methods. It hasn't changed at all. The difference between accessing that or accessing self-rear is constant, so it's still all the same. Okay, so we continue. Differences in red. What about append? How do we do append? Well, the exception is going to be the same because we just call is full. If we had, look at that, if we actually had put the code here, we'll be having to change it. That's why it's so good to reuse. Okay, and exactly the same, and this is the difference. That is what is allowing us to wrap around the end of the array. This is what is called modding, and I'm modding a value by the length of the array, which means that imagine that the length of the array is 6 and self-rear reaches 6 modded by 6 is 0, right? The remainder of 6 divided by 6 is 0, and therefore boom, it goes all the way, wraps around. What is the big 0 of this? Well, exactly the same as the one before, which basically means constant. What about serve? What happens if front reaches the end of the array? Well, let's have a look visually. So I'm here and I want to serve. What do I need to serve? Well, whatever is pointed by front, which is 13. How do I do this? Well, I'm also going to have to wrap, right? Because I need to put front to next to pointing to 23. So what happens if we serve now? I just wrap around and look what has happened. Length has gone from 3 to 2. Front has gone from 5 to 0. Again, 5 plus 1, 6. 6 modded by 6, 0. And I return B0. So what is the implementation? Serve. if is empty, exception, all this is identical, self-length, all this is identical, and this is the difference. Again, front wraps around the array, I'm modding by the length of the array, and then I return the item. And that's it, as simple as this. Big O? What do you think? Well, again, the only new thing that it's doing is this. So the same as before, which was constant, is constant too. And that's it. Let's have a look at the invariant. Before we said the valid data appears from where? From front to rel-1 in that order, right? Well, what about now? Well, if front is less or equal than rel, exactly the same, from front to rel-1 in that order. And otherwise, it goes from front to the end of the array, and then from 0 to rel-1 in that order. That gives you the order in which things are entered in the queue. And that's it. That's how incredibly simple circular queues are. And that we have reached the next block, and we'll see you then extending and using our queue. See you. Bye.